Hello everyone, this is Poornima Deepthi working as an assistant professor in the Department of ECE at MLR Institute of Technology. Today's video is about the architecture of 8051 microcontroller. So this video is a part of microprocessors and microcontrollers. So coming to the overview of today's presentation, I will be telling about the architecture of 8051 and the register organization and special function registers, SFRs and input-output ports of 8051 microcontroller. Coming to the features of 8051 microcontroller. So in early 1981s, this 8051 microcontroller was designed in the Intel's lab. So it is an 8-bit microcontroller. So as I already told you, it is a ALU which performs 8-bit operations for a single clock cycle. So it is having 40-pin DIP package, so dual inline package. So the IC which 8051 is consists of 40-pin IC. So it has internal memory ROM of 4 kilobytes and internal RAM of 128 bytes. To store the program memory, 4 kilobytes is there. To store the data, 128 bytes is there. So it has two 16-bit registers. So T0 and T1 timers, two 16-bit timers, T0 and T1. So timers 0, they are having represented as this. So this is the lower of T0 timer 0 lower byte, and this is the higher byte of timer 0. So 16 bits has been splitted into two 8-bit timers. TL0 is the lower byte of timer 0 and TH0 is the higher byte of timer 0. That for timer 1 also it is having TH1 and TL1 of the two 8-bit registers. It consists of 4 parallel 8-bit ports. So 4 parallel 8-bit ports, port 0, port 1, port 2 and port 3. Each port is having 8 input-output lines. So total 32 input-output lines is there, and it is having the crystal oscillator. It is having inbuilt crystal oscillator which can produce the crystal frequency of 11.0592 megahertz. Sometimes it may take we may take it as 12 megahertz also approximately. So in precisely 11.0592 megahertz clock frequency is generated by the crystal oscillator already inbuilt in the chip itself, 8051 chip itself. So coming to the block diagram of 8051. So we are having in 8051 block diagram, we are having the 4 input-output ports. So as I already told you, port 0, port 1, port 2, port 3, each one of these ports is having 8 bits. So total 32 input-output lines is there, and that 32 input-output lines will be in the 4 input-output ports. And our 8051 will support UART, Universal Asynchronous Receiver Transmitter Serial Communication. So to transmit this data and to receive the data, we will be using this communication ports. So this is the serial port which can be used for the communication, serial communication. So TXD is the transmission and RXD is the reception of the data. So coming to here, we are having 8051 supports two 16-bit timers. Timers or counters. Timers is used to provide the time delay, where counters is used to calculate the number of events happening outside the or external things. So coming this one, we are having two timers. Each one is of 16-bit. Timer 0 and timer 1, and here we are having internal memory. So on chip RAM is there. RAM is of 128 bytes, and on chip ROM is there. It is having of 4 kilobytes. And not only this, 8051 can support external memory up to 64 KB. So it can support external memory up to 64 KB RAM and ROM, both program and data. So here another important block in 8051 is interrupt control. So here in 8051 it can support five interrupts. So 2 are external interrupts and 3 are internal interrupts. Out of these 3, 2 interrupts is for timers and 1 interrupt is for serial port communication. And CPU, which performs the logical and arithmetical operations, the processing will be done using the central processing unit, and this is the oscillator which generates 11.0592 megahertz of clock frequency. This is the crystal oscillator having inbuilt in 8051 chip itself. So this is the bus control which is used to transfer the data within or outside the microcontroller. So this is the block diagram of 8051 microcontroller. So coming to the general purpose registers of 8051. So here 8051 is having total registers present in 8051 are 21 registers, including special function registers, general purpose registers, program status word, everything. There will be 21 registers in 8051. So most of the registers are 8-bit registers apart from 3 registers. So that 3 registers are timer registers are of a 16-bit and DPTR, data pointer. So this is the 16-bit register which again this 16-bit registers use it as 8-bit registers, data pointer higher byte and data pointer lower byte. This register is used to hold the external memory address of data being fetched if we are using external data, and here data pointer used to hold the address of the data which will be storing. So coming to the program counter, another 16-bit register. So it is a 16-bit register which holds address of the instruction next executed. So it will store the next executed instruction address. So it increments automatically when we fetched the next instruction. If the next instruction has been executed, then it increments address will be incremented and next instruction will be fetched. So coming to the accumulator, as accumulator is a general purpose register, here accumulator A is there and B. So these two are the general purpose registers used for the normal data transmission or reception. Here 8-bit register, it is an 8-bit register. This register is used for data transfer and arithmetical and logical operations, and after completion the operations, most of the time the output will automatically saved in this accumulator. While coming to the B register, it also stores, it is a general purpose register. It can use for any other purpose. Apart from that, in particularly in arithmetical operations, while we are doing multiplication and division operations. So as I already told you that 8051 is a 8-bit microcontroller. So it can perform 8-bit operations at a time. So if 8-bit data, so like if I want to multiply 88 with 22. So there is a high chance of getting more than 8 bits as an output. Suppose if we are getting 16-bit output, for assumption I have taken this, not exactly the value. So if we are getting 16-bit output, so the output where it will store, most of the cases the output will be stored in the accumulator itself, A register. Now here we are having 16 bits of output. So accumulator can support only 8 bits of data. So the remaining 8 bits of data, so there is a 16-bit of data. So here in particular in this case, not only in this case, in division also. If we are performing division, there will be 2 outputs. One is coefficient and another one is remainder. So in this particular 2 scenarios, while we are performing multiplication and division operations, the B register is automatically used to store the other 8 bits of operations. Here the lower 8 bits of data will be stored in the A register and the higher 8 bits of data will automatically store in the B register, only in the case of multiplication and division operations. While in the division operations, these two registers will hold, A and B registers will hold the actual data. So A and B registers will hold the outputs, coefficient and reminder. So coming to the stack pointer. Here stack pointer is also a register which is used, it is a 8-bit register which holds the address of the stack. If we want to store, suddenly if any interrupt occurs, the microcontroller need to store the intermediate results until execution. So in that particular case, a stack will be used to store the data. So the data, to retrieve the data already stored in the stack, we must hold the address of that particular stack. So this address of that stack will always be stored in stack pointer. So while we are incrementing, stack pointer will be incremented before data is stored onto the stack using push instruction or call instruction. While we need to retrieve the data, we can use the pop instruction. In particular pop instructions, the stack pointer will be incremented. So the next important register is PSW, program status word, also known as flag register. So the flag register is here in the case of 8051, it is a 8-bit register which is used to show the status of the output. So while we have performed any operations or we have completed one particular program, so the output, the status will always be shown here. So in PSW, it is a 8-bit register. The first one, the PSW 0. So PSW 0, least significant bit. So it shows the parity bit. So what is a parity bit? So if we want to find whether the given output is having even parity or odd parity, so that one is represented by P. Here in PSW1, it is user definable flag. So coming to the OV is the overflow flag. So if overflow, so our registers hold 8-bit data if more than 8-bit of data. So in the previous example, we have been using this one. Here the output is 16-bit. So our registers can hold 8 bits data only, 8 bits only. So in that particular case, overflow flag will enable. So representing that some part of output, the register can't hold the total output, like that. Overflow is there. So coming to the next two things, PSW3 and PSW4, these RS1, RS2 are known as register select. So here it register select banks. There are 4 banks in 8051. So if RS1, RS not. If those two are 0, bank 0 will be selected. If these are 0, 1, bank 1 will be selected. 1, 0, bank 2 will be selected. And for 1, 1, bank 3 will be selected. So each bank is having 8 registers R0 to R7. So each bank is having R0 to R7 registers. If some, in any case of like, if I want to move data from R2 register to accumulator, basically if we write like this, so the R2, the data present in R2 register will be moved to the A register. So every register here we are using R0 to R7, and A and B registers are 8-bit registers. So data will be moved. It automatically selects bank 0. So if I want to select bank 1 R0 to R7 registers, then you need to here set or reset. So I'll be explaining this while using this, while explaining the program. So basically register banks, there in 8051 there are 4 register banks, and each bank is having 8 registers R0 to R7. You can use which register you want in single bank. So coming to the next PSW5, it is a general purpose flag register, status flag. So coming to next one, auxiliary carry. So while we are performing any operations like arithmetical operations, if we are performing any additions, So if I want to perform any additions, 9 plus 2, here everything microcontroller is also using hexadecimal numbers only. If I want to 9 plus 9. So there must be the carry. So if the lower nibble is having the carry, that carry is known as auxiliary carry. If the total, we are having total output after completion of 8-bit operation, if we are having carry, that will be represented by this carry. But in the case of auxiliary carry, if the carry is generated at the lower nibble of data, so such type of carries are known as auxiliary carry. So it will show, this particular auxiliary carry will show the general purpose auxiliary carry will show if any carry is there in the nibble. So coming to the, if we are getting the carry as total after completion of 8 bits of data, then this carry bit will be enabled. Otherwise, it will be 0. So how to select this RS1 and RS0 register banks? So in 8051, there are 4 register banks: bank 0, bank 1, bank 2, bank 3. And each bank is having R0 to R7 values, R0 to R7 registers. So here, all these are the RAM locations of that particular register. So these registers, the data present in these registers will be always stored in the RAM locations, because the registers holds the data. So data will be stored in the RAM. So the locations, always RAM will start the locations with these 4 banks. So R0 of bank 0 will be in 0 to 7. So next, A to F. Why A to F? Because here in 8051, everything will be related to the hexadecimal numbers. So hexadecimal numbers representation will always start from 0 to 9 and A to F. So usually we will represent A as 10 and B as 11, C as 12, D as 13, E as 14 and F as 15. So after that, it will again starting from 1011. These are the hexadecimal number locations. So these particular banks will hold that particular RAM locations. So at a time, we can use only R0 to R7 of single bank, not 4 banks at a time. So coming to the SFRs, here there are SFRs of 8051 microcontroller. So coming to the timer block, there are 2 special function registers in timer block, T-mod and T-con. So T-con is a timer control, when to stop the timer, when to start the timer, and out of 2 timers, which timer need to be started or which timer need to be off, and 2 interrupts, timer interrupts, TF1 and TF0, like that. And this is the T-con, timer control, configures and manages the operations of 8051, both the timers, including start and stop, control and overflow flags. So coming to the T-mode. T-mode is a timer mode. Actually here in 8051, there are 3 modes of timer, 4 modes of timers. So we will be using 3 modes of timers. So these timer, 16-bit timer can be used as 16-bit timer or 8-bit auto reload timer or 13-bit timer, and another one is split mode timer. So these 4 modes will be there. So to select the modes of timers, we will be using this T-mode special function register. TL0, TH0, these are the timer 1 lower and higher bytes. TL1, TH1, these are the timer 1 lower and higher bytes. So next, coming to the SCON, SBuffer, PCON. So these 3 special function registers comes under the serial communication port or serial port. So as already told you, that serial port supports the communication in 8051 microcontroller to the other peripheral devices. So it supports UART, Universal Asynchronous Receiver Transmitter. So so to hold the data, you must have one general purpose register, like special function register. Here serial buffer is used to transmit and receive the data. So if the data want to be sent out, so that data usually will be stored in the S buffer. If any reception of data is there through the communication channel, communication port, that data will always be stored in this S buffer register. Coming to the SCON, serial control. So to configure 8051 serial port, how much baud rate it needs to support. So again, what is a baud rate? Baud rate is number of bits transmitted per second. So here to set the baud rate or how much rate will be there, data reception and transmission flags, everything will be there in the serial control register SCON. Now coming to the PCON, as I already told you that 8051 can be operated in data ideal mode and energy efficient mode. So to control the power of that particular modes, or to keep the microcontroller in the sleep mode, you can use this PCON special function register. So coming to these two registers, IE and IP. So as I already told you, we are having interrupts. So interrupt block is there in 8051. So in interrupt blocks, there are two special function registers, IE and IP. Interrupt enabled and interrupt priority. So which interrupts need to be performed first? If as I already told you, there are 5 interrupts, right? So 2 external interrupts and 3 internal interrupts. If 2 interrupts enabled at a time, so which interrupt need to be performed first? So there should be the priority. So to tell the microcontroller to execute these particular interrupt first, to set the priority of executing the interrupts, so we will be using this interrupt priority. So how to, if I want to enable this particular interrupt, or a controller need not enable interrupts, it need to disable interrupts. So if to enable or disable the interrupts, this special function register IE will use that, will be used for that particular process to enable or disable the interrupts. So these all are the important SFRs, special function registers present in 8051. As we are dealing with the timers and serial port and interrupts, I will be explaining them in detail by its original register set. So coming to the input output ports of 8051. So there are 4 input output ports: port 0, port 1, port 2 and port 3. Usually these all ports can be used as general purpose input output ports. It can use it for taking the inputs, or it can be used for sending the outputs. Apart from those, there are specific functions which can be operated by port 0 and port 2 and port 3. Specifically, port 3 is used for the interrupts handling port also. So coming to the port 0 and port 2, as I already told you that a microcontroller can be interfaced. Microcontroller can access external memory up to 64 KB. To support 64 KB of external memory, it need to have 16-bit address lines, right? So that 16-bit address lines. But here in the case of 8051, the ports which we are using, port 0, port 1, port 2, port 3, each one is having only 8-bit port. So how this external 16-bit address will be supported by these ports? So in combination with port 0 and port 2, by using port 0 and port 2, these address bits can be supported to access the external memory. So it can be used as normal input output bidirectional port, and it can use it for address and data interface for accessing external memory. Here in the case of port 2 also, higher external address byte. So here address byte A0 to A8 and A0 to A7 and A8 to A15. So this lower order address will be accessed by port 0, and this higher order address will be accessed by port 2. So not only a data address, it can access data also, 16-bit data, if RAM is used as the external memory. So coming to the port 3. Port 1 is only dedicated for input output interfacing, only for input output purpose only. While coming to the port 3, each pin of port 3 is having unique purposes. So it can serve for the interrupts also. It works as input output port, same like remaining ports, as well as it has alternate functions also. What are the alternate functions of port 3? Coming to the port 3. So P3.0. So this will be used as receive port in the serial communication. So to receive interrupt for the serial communication, serial input data, serial port. 3.1 is used for transmitted interrupt. If transmit interrupt is there, serial output data. So 3.2 and 3.3 internal. These two are the external interrupts. To access external interrupts, these two pins will be used. So T0 and T1, timer 0 and timer 1 flags, timer 0 and timer 1 flags. So coming to the P3.6, it is a write. So external memory write enable, external memory read enable, write operation and read operation. These are the alternate or specific functions of port 3 of 8051. So until now, I have discussed the block diagram of 8051 and some of the features of 8051 microcontroller and register organization, PSW, special function registers, program status word, and ports of 8051 microcontroller. Thank you.